Welcome to week 3 of online learning. In our last lesson, we examined compositions of transformations. In this lesson, we're going to examine dilations about the origin. A dilation is a transformation that produces an image that is similar, the same shape, to the original pre-image, but is a different size. In example 1, we're going to look at dilations in the origin that have a scale factor that is greater than 1. We use the variable k to represent the scale factor. Here we have a triangle ABC, drawn in quadrant 1. The vertices for this original figure are here. So what I'm about to do is I'm going to dilate this triangle. And now I dilate it by a scale factor that's greater than 1. So what do we notice when we dilate it by a scale factor that's greater than 1? We still have a triangle, but the triangle over here, since the scale factor was greater than 1, is now larger than this original triangle. And we can compare the coordinates. So here, A is located at 5, 1 in the original figure. But in our dilated image, A is now at 10, 2. So what we have to think about is, what is the scale factor? And how does it affect the coordinates? So if we were to compare them, let's see if I can move these coordinates up over here. Okay. How do we go from 5 to 10, or from 1 to 2? We can also look at the coordinates for B and B prime. B is at 6, 4. B prime is at 12, 8. C is at 7, 2. C prime is at 14, 4. So hopefully what you've noticed is we took the original coordinates and we multiplied it by the scale factor. And the scale factor here is 2. 5 times 2 is 10, 1 times 2 is 2, 6 times 2 is 12, 4 times 2 is 8, 7 times 2 is 14, 2 times 2 is 4. So here, our original image and our dilated image, the dilated image has a scale factor of 2. So if I were to compare the measurements of side AB and side A prime B prime, you notice side A prime B prime is double that of side AB. What do you think happens to the angles in a triangle when we dilate in the origin? Key concept. We have a dilation in the origin by a scale factor of k. We take the original coordinates and we multiply each coordinate by the scale factor. So in our last example, the scale factor was 2. So we multiplied the x and the y coordinate by 2 in order to get our dilated image. Now we're looking at a dilation with a scale factor greater than 0 but less than 1. What happened to the triangle this time? Hopefully you said it got smaller. Because when we multiply by a scale factor that's greater than 0 but less than 1, the image is going to decrease in size. And we can compare the coordinates again. So if we're looking at the coordinates here, the dilated figure versus the coordinates of the original figure, what's the scale factor this time? How do we go from 5 to 2.5, 1 to 0.5, 6 to 3, 4 to 2, 7 to 3.5, and from 2 to 1? If you said multiply by a scale factor of 1/2 or 0.5, you are correct. This image is now half the size of the pre-image. And we can measure the distance between the sides here. So there's A prime, B prime. And if we bring back our original one, okay, it is now half the size. And we could do that for all of the sides of the triangle. My question to you was, what happens to the angles in the triangle? Now, the cool thing that we can do here with the program that I'm using is that I can grab, I'm just going to move this out of the way. I'm going to grab any of these coordinates and I can move them. So if I grab the pre-image and I move this coordinate, look what happens. All of the angles are changing. Notice they're staying the same though. The angles in the original image and then the dilated image. Okay. You can bring it down here. You can take another. Here we have the dilated image is now within the original image because we are crossing through the origin. But notice the angles of the triangle are still going to be the same no matter where I move these coordinates to, because they are similar triangles. The original triangle and the dilated triangle, the angles are going to be the same. The side lengths are going to be different, but all of the angles are going to be the same. And that's no matter where I move any of these coordinates, we can move them all about. And those measurements are going to stay the same. Okay, so I hope you found this lesson interesting. And today in your classwork assignment, you are going to be looking at some dilations along with some other transformations, and you are going to try and decide the composition of transformations that have occurred with a guided practice on Delta Math. And then don't forget to answer the one problem of the day so that I can give you your participation points. Math allows thinking to happen. Keep thinking.